Hi everyone and welcome back. So in this module we will be discussing on introduction to big data and Hadoop. So here we'll be discussing on different concepts of big data. We are going to explain how Hadoop works and how it addresses the big data challenges. And then we'll be discussing the components of the Hadoop ecosystem as we proceed further. So big data, as we had discussed in our first module, so it's a term that we use for collection of data sets that are large and complex and which is difficult to store and process using available database management tools or traditional data processing applications. So the challenge includes capturing, curating, storing, searching, sharing, transferring, analyzing, and visualizing of this particular data. So it has multiple components, or we can say characteristics, like we have volume, variety, velocity, veracity, and value. So volume refers to the amount of data which is growing day by day at a very fast pace. The size of data is going to be generated by humans, machines, and their interactions on social media itself is massive. Now researchers they have predicted that 40 zettabytes of data will be generated by 2020, which is an increase of 300 times from 2005, and now we are in 2022. So that means we are already surpassed almost 50 zettabytes of data. So then we have velocity. So velocity is defined as the pace at which different sources they generate the data every day. So this flow of data is massive and continuous. So there are 1.3 billion daily active users Facebook has, which is an increase of 22% year-over-year growth. And this shows how fast the number of users are growing on social media and how fast the data is getting generated on a daily basis. So if we are able to handle the velocity, we will be able to generate insights and take decisions based on real-time data. Then we have variety of data. So as there are many sources which are contributing to big data, the type of data that they are generating is different. It can be structured, semi-structured, or unstructured data. And that's why there is a variety of data which is getting generated every day. Earlier we used to get the data from Excel and databases. Now the data are coming in the form of images, audios, videos, sensor data, and so on. So this variety of unstructured data creates problems in capturing, storing, mining, and analyzing the data. Then we have veracity, which is basically something that refers to data in doubt or uncertainty of data available due to data inconsistency and incompleteness. So data available can sometimes get messy and may be difficult to trust. With many forms of big data, quality and accuracy are difficult to control, like Twitter posts with hashtags, abbreviations, typos, and multiple speech difference. So the volume is often the reason behind for the lack of quality and accuracy that we refer as veracity. And then we have value. So after discussing this, value should also be taken care of when we are looking for big data solutions. So it's all well and good to have access to big data, but unless we can turn it into value, it is useless. So by turning it into value, we mean that is it adding the benefits of the company who are analyzing the big data? Is there going to be any kind of monetary benefit from that analysis that we are going to do, either short term or long term? Then only it is going to make sense to have the data extracted and investing the team that is going to perform the analysis. So without that, there's no point in investing in big data implementation. And there are different ways of traditional decision making, which are what we think we are going to use our experience and intuition. We are going to use a rule of thumb which is going to follow a fixed path. And these were the challenges for the traditional decision making. So because it takes a long time to arrive to a decision and therefore losing the competitive advantage. If we are going to delay, then a competition will simply go ahead of us. And it requires the human intervention at various stages, and that's why when we have so much of data coming in from different sources, We cannot automate that, and it lacks the systematic linkage among strategy, planning, execution, and even reporting as well. And it provides limited scope of data analytics. That is, it provides only a bird's eye view, not the deep insight, okay, how the entire trend is going to be. And it obstructs a company's ability to make fully informed decisions, which is a key factor of staying alive, or you can say staying in competition. Because if you take a look for last 2 decades, then companies, those who have relied heavily on big data, only those companies they have survived, like Google, Microsoft, Apple. So certain companies they have survived because they kept themselves updated, and they keep on revising the entire strategic components by using these components. So that is the main advantage that it has. If you talk about the big data analytics, then it's based on what users know, which in turn is used to provide the good analysis. It provides a comprehensive view of the overall picture, which is a result of analyzing data from multiple sources. So it provides a comprehensive view of the overall picture, which is going to help the companies in getting to a better decision. It provides a streamlined decision making from top to bottom, so that we have a complete analysis, or we have a complete picture, so that we don't miss out on anything when we are taking up a decision. And it helps in analyzing the unstructured data, which is going to be a tedious task. When we say unstructured data, we simply refer to data in the format of audio, video. So these are examples for unstructured data set, and it helps in faster decision making, and thus it allows us to have that kind of competitive advantage as compared to others, so that by the time our competition will take the action, we would have implemented the components accordingly. That's how it is going to be. So there are multiple components here. So if you take a look at the entire pipeline, so when we say pipeline, so basically here it involves different components. So where it shows a complete sequence in which the raw data is going to be ingested into our pipeline, and how it is going to be processed by which all tools, and how it is going to be saved as a process data. So as you can see here, from the leftmost corner, we have data coming in from different sources, which is going to be first of all ingested by tools. For example, we can store the structured, semi-structured, or the unstructured data in S3, which is a solution, which is an object storage service offered by AWS. It can be stored in HDFS, which is a Hadoop distributed file system, or any kind of other cluster file systems. And then from there, it is going to be moved on to the data processing layer, where we can perform the batch processing for the past data which has already been recorded. We can perform the real-time processing for the data which is coming on a continuous manner, like a Twitter feed, or we can go for a mix of both. And then it is going to be sent to the data query layer, where we have tools like we have Spark, SQL, Redshift, which is offered by AWS, Presto, or Hive. And then it goes to the analytics engine, where we can perform different type of analytics, like we have the statistical, semantic, predictive, and text based on the data set and based on what we are trying to achieve. And then we try to visualize the data by using different BI tools, like we have Power BI, Tableau, we have real-time dashboards or recommendation engines that we can work with. So this showcases the entire pipeline, or we can say the sequence in which different components are going to work together. Hi everyone. So in this video, we are going to talk about the case study of big data using NVIDIA Jetson camera. So a semiconductor manufacturing firm like NVIDIA is testing chips in traditional ways. So total of 1.3 million chips are made, and a person is required to test and validate if the chips are ready to be dispatched to the dealers or not. It takes around 8 minutes to test a chip, and the company wants to reduce this time to increase the production. So what it does, so basically the company installs 6 NVIDIA Jetson cameras in the testing utility to create a fully automated system for fast processing. So basically it captures real-time photos of chips and sends them to the Hadoop big data pipeline for processing. So when the images are received into the system, the ETL is performed on them to remove noise and transform them into fixed pixel length images. And the images are then dumped into the Hadoop system for further processing. So if the Hadoop system rejects some images, the batch of chips is manually checked by humans to remove any defects that may be present of whatever kind. And it is estimated that Hadoop system testing was nearly 95% accurate, with 5% requiring manual intervention, which is a significant advancement in chip manufacturing, thus allowing the company to manufacture more chips, and that too in near time, in less amount of time as possible. So what exactly big data is? So the 5 characteristics that define big data are volume, veracity, variety, and value. So the big question is, what exactly big data is? So big data is basically a term that is used for collection of data sets that are large and complex, which is difficult to store and process using available database management tools or traditional data processing applications. So the challenge includes capturing, curating, storing, searching, sharing, transferring, analyzing, and visualization of this particular data. So that's why we can refer to the large data sets that may be analyzed computationally to reveal the pattern, especially relating to human behavior and all the available interactions. So at any given minute, so there are 28,000 subscribers who are watching Netflix, almost 700,000 stories are shared, 9,000 connections are made, 69 million messages are being sent over WhatsApp and Messenger. There are 5,000 downloads on TikTok, and there are more than 2 million views in terms of text. There are 1.6 million USD spent online every minute. There are 2 million swipes on the dating apps, 119.7, or we can say 197.6 million emails are being sent, which includes promotional emails as well. And there are 500 hours of content uploaded every minute on YouTube. So in terms of different types of data, it can be divided into 3 main parts. Like we have unstructured, semi-structured, and then structured data set. And now we also have quasi-structured data set. So if we talk about structured, then here the data that can be stored and processed in a fixed format is called as a structured data. So data stored in a relational database management system is one of the examples for structured data. So it is easier to process structured data as it has a fixed schema, and structured query language, which is SQL, is used to manage such kind of data. Then we have semi-structured data, which is basically a data type which does not have a formal structure of a data model, like a table definition in a relational DBMS. There is no schema involved here. That's why it is called as a schema-less structure. And it has some organizational properties like tags and other markers to separate semantic elements that makes it easier for anyone to analyze it. So XML files or JSON files, they are examples for semi-structured data. Then we have quasi-structured. So again, this is like a textual data with erratic formats that can be formatted with efforts. Like we have the clickstream data coming in from ad tech engines. Then we have unstructured data. So basically the data which have we can say known or unknown format and cannot be stored in the RDBMS, and it cannot be analyzed unless it is transformed into a structured format, and that is called as a unstructured data. So text files with multimedia contents like images, audios, videos, they are examples for unstructured data. So the unstructured data is growing quicker than the others, and right now 80% of the data in any company, they are all unstructured. So that's what we have in terms of the different types of data. And in terms of data growth, so it is estimated that data will rise exponentially by 2025 to around 175 zettabytes. So there are 5 V's of big data that we have to consider. So the first V that we have is the volume, value, veracity, variety, and velocity. So if we talk about data volume, so volume refers to the amount of data which is growing day by day at a very fast pace. So the size of data generated by humans, machines, and interactions on social media itself is massive. So researchers, again, as we had discussed earlier, it is going to reach around 175 zettabytes by the next couple of years. Then we have velocity. Velocity is defined as the pace at which different sources generate the data every day. So this flow of data is massive and continuous. So there are more than 1.3 billion daily active users on Facebook on mobile as of now, which is increased of 22% year over year. And this shows that how fast the number of users are growing on social media and how fast the data is getting generated on a daily basis. So if we are able to handle the velocity, you will be able to generate insights and take decisions based on real-time data set. Like Amazon records every click made when customers browse the website. Then we have variety. So as there are many sources which are contributing to big data, the type of data they are generating is going to be different. So it can be structured, semi-structured, or unstructured data. And that's why there is a variety of data which is getting generated. And earlier we used to have data from the Excel and databases. Now the data is coming from different formats, including images, audios, videos, sensor data, and so on. So the variety of unstructured data creates problems in capturing the storage, mining, and analyzing data, so we can store them in a separate data frame if we want. And then at last we have veracity. So veracity refers to the data in doubt or uncertainty of data available due to data inconsistency and incompleteness. So data available can sometimes get messy and may be difficult to trust. So with many forms of big data, quality and accuracy are difficult to control. So Twitter posts with hashtags or the abbreviations, the typos, this is all defined by using the veracity. So the volume is often the reason behind for the lack of quality and accuracy in a given data set. And at last we have value. So this should be taken care of as well. So value, it is all well and good to have access to big data, but unless we can turn it into a value, it is useless. So by turning it into a value, we mean, is it even adding to the benefit of the company who is trying to analyze the data or not? Is a company which is working on the big data achieving high return on investment or not? So until and unless it adds to their profits by working on big data, it is going to be completely useless. So these are the 5 V's of big data. So the advent of big data seemed to rise a new way of dealing with unstructured data. So basically it allows us to centralize the data and apply big data analytics to the problem. So as we discussed, unstructured data includes multimedia components, social media data set, web logs, and semi-structured contains data in the JSON or in the XML formats. So now we will be talking about the case study where we are going to consider Royal Bank of Scotland as an example. So 100% of the data can be processed, whereas only 3% could be processed earlier with the traditional systems for this bank. So basically there are 250,000 customer chats per month launched for multiple banking requirements, and there are large volumes of unstructured web chat data currently available there, and 200 chats manually are extracted per month and analyzed for quality assurances. So this is the previous web chat analysis a company had been following. So the main challenges of a traditional system are what? There are 3 main challenges that we face. growth rate, data size, and the unstructured data. So when we say growth rate, that means data is going to be generated at a high velocity. That means the traditional RDBMS systems, they are not, we can say, designed for handling that, and that's why this is a shortcoming for the traditional systems. Like we have the RDBMS and data warehouse systems. Then data size is also increasing as we speak. So data can range anywhere from terabytes to exabytes, and data is majorly available in the unstructured format. So relational databases, they cannot categorize or uncategorize, or you can say the unstructured data set. And that's why these are the different advantages of big data. It can run anywhere we want. That's a main advantage that we have here. There is no dependency, and it can process all type of data, be it structured, semi-structured, unstructured data set. And it has better decision making, because here we are going to get the insights based on the data, which is going to allow us to take better decisions. And it processes huge data quickly in the real-time scenario. So there are a lot of companies, almost all Fortune 500 companies, they are using the data analysis in one way or the other in their company, having multiple team members on board. So it includes IBM, Microsoft, SAP, Fujitsu, Google, Facebook, Siemens, Boomerang, Coca-Cola, PwC. There are endless number of companies available. Next, we can analyze the same thing in big data for Netflix. So Netflix, enormous user base of over 148 million users, offers it a big advantage when it comes to data collection, because it has a good number of users who can and who are generating data for it. So for example, when do users watch a show, and where do they watch it? They watch it on their phones or televisions or tablets. On which device do they watch the show? How often do they pause a program? So that simply allows us to know, okay, what exactly is the frequency with which they are going to watch a given show, and are there any interruptions in the background that they are watching the show on, and so on. And how often do they re-watch a program? That is going to make sure they are, okay, this type of genre is something of their favorite, or they really like this movie or a show, and do they skip credits or not, or they do like to watch it, and what are the keywords search, so that these all things can be used for improvising the recommendation system offered by the solution. So traditionally, the analysis of such data was done using computer algorithm, and that was designed to produce a correct solution for any given instance. So as the data started to grow, a series of computers are employed to do the analysis, and they are also known as the distributed system that we have here. So that's all for this entire video, everyone. So in the next video, we are going to talk about the distributed systems concept. Thank you for watching the video.